All right, we're going to solve systems by elimination. So the first thing that we want to do is we're going to look at our variables. Okay. And then our goal is to try to figure out if the x's in the top and the bottom are the same, or if the y's in the top and the bottom are the same, and if they're not, we'll have to make them the same. So, for example, in the first problem here, we have 2x and 6x, so those aren't the same. And then we have a 5y and a negative 5y. So when I say same, I mean that the number, the coefficient needs to be the same. But the sign in front of it needs to be the opposite. So this is a perfect scenario for us. So we're going to add these down because we're trying to eliminate one of the equations. So we are eliminating the y terms because a positive 5y and a negative 5y cancel out. Then we're going to add 2x and 6x, which creates 8x. And then we're going to add 17 plus negative 9, which is essentially just like 17 minus 9, and you get 8. We're going to solve for x. So x equals 1. Then we need to plug that 1 in, and you can pick either equation. We're going to plug it back in so that we can find the y value. So 2, I'm going to choose this top equation here. So 2, and instead of x, we're going to put 1 because we now know that the value of x is 1. So 2 times 1 plus 5y equals 17. 2 times 1 is 2. Plus 5y is 17. We need to get the y by itself and divide by 5. So the y value, 15 divided by 5, is 3. So our solution that we're going to write for this problem is going to be 1 for the x value and 3 for the y value. All right, let's look at number 2. Okay, so number 2, we have a 3x and a 3x, and then we have a 3y and a negative 4y. So what we have is we have the same number for the x's, but they are not opposite. So we can just make one of them opposite. So basically we're multiplying the entire bottom equation by a negative. So we're going to make that a negative 3, so it's just going to change the signs. A positive 4y, and then that's going to be a negative 5y. All right, and then, just as in the first one, we're going to add down. So 3x combined with negative 3x is going to cancel. 3y and 4y is 7y. And negative 5 and negative 9 is going to be negative 14. Divide both sides by 7. Y is negative 2. So this time we know the y value, and now we're going to plug back in to get the x value. So we can choose either equation. I'll just choose the top one again. So 3x plus 3, and this time we do know the y value, so we can put it in as negative 2 equals negative 9. So 3x, 3 times negative 2 is negative 6 equals negative 9. Add your 6. 3x equals negative 3. Divide by 3. So x is negative 1. And so to write the solution for this one, our x value goes first, so negative 1, and then our y value goes second, negative 2. All right, we can look at number 3. So here we have a 1x and a 2x, and a 3, and a 7. So you really have an option to make whichever one the same that you would like. What I like to do is make it as simple as possible. So if I multiplied the top equation by 2, that would give me the same 2x. And then remember that we want one to be positive and one to be negative. So we'll just go ahead and make the top one negative. If we distribute that out, our new equation would be negative 2x minus 6y equals negative 12. And then we have our second equation, just goes right over, okay? And that is positive 2x minus 7y equals negative 1. Now, we're going to add those two together to eliminate one of them. The positive 2 and the negative 2x are going to cancel. Negative 6y and negative 7y is negative 13y. Negative 12 plus negative 1 is negative 13. Divide both sides by negative 13. The y value is positive 1. Then we're going to take that and plug it back in to either of the equations. I typically like to just pick the top one. So x plus 3, and so we're going to plug this 3 in for the y. Or I'm sorry, the 1 in for the y value beside the 3. And solve for x. Okay, so the solution is going to be your x value, which is 3, and your y value, which is 1. All right, we've got another one here. We've got an x and a 2x, and we've got a 4 and a negative 1y. We could do the exact same thing for number 4 that we did for number 3, but I'm just going to give you a different example. Either way will work. There are so many different ways to solve these. But for this one, I'm going to try to make my y's the same because I already have one positive and one negative. So what we can do is we can multiply the bottom one this time by 4. So our new equation would be, if I distributed that, 8x minus 4y equals 32. That's just from distributing. And then our top equation would be the same as it is. We're just going to move it over. So that creates x plus 4y equals 13. And then we can add those down. So 8x and 1x is 9x. Our 4 y's are going to cancel because one's positive, one is negative. And then we're going to add 13 plus 32. So we're going to get 45. Divide by 9. So x is 5. Then we're going to plug that in. Like I said, I always like to plug it into my top equation. So if I know that the value of x is 5, I'm going to take this top equation, and I'm going to do 5 plus 4y equals 13. So I plug that in and solve. So we'll do minus 5 on both sides. And 4y equals 8. Divide by 4. Your y is 2. So when you write your solution, x then y, so we're going to write 5 and 2.